Hey everyone, and welcome back to Idea Mechanics. Now, for anyone new here, TRIZ is basically a powerful cheat sheet for systematic innovation. It helps us turn problem solving from a random aha moment into a science we can actually repeat. And today, we're using one of its coolest principles, Principle 31, to build software that doesn't just work, it actually breathes. Let's dive right in. So, let me ask you this. Think about the last time an app just felt sluggish. You click something and you just wait. That delay, that bottleneck, it usually happens because the system was built like a solid block of concrete, trying to handle everything at once. But there is a much, much smarter way to design things. If you're ready to stop relying on luck and start mastering systematic discovery, go ahead and hit that subscribe button to join the Idea Mechanics team. And don't forget to ring the notification bell so you're the first to see our next innovation breakdown. We want to build this culture with you, so drop a comment below and tell us which TRIZ principle or tech challenge we should tackle next. Okay, let's get into it. The old way of building things is what I call the solid concrete trap. Just imagine every single user request having to line up, single file, to go through one narrow path. The system just plows through every task, one by one. It's a brute force approach, and honestly, it just crumbles the moment things get busy, leading to those painful wait times. What we really need here is a total mindset shift, which our lead innovation catalyst, Kai, is showing us perfectly right now. We're moving away from that old trial and error game, building these huge, rigid monoliths and just throwing more servers at the problem when it slows down. Instead, we're adopting the TRIZ way, a systematic discipline of designing elegant, porous systems that are actually built to be flexible and to scale. And that brings us to the core idea for today, the porous system. Now, TRIZ Principle 31 actually comes from the physical world. Think about materials like sponges or aerated concrete. They have tiny holes that make them lighter or stronger or better insulators. The absolute genius of TRIZ is that these principles are universal. We can take that exact same idea and apply it to how we build software. So what on earth does a porous system mean in the world of code? Well, as you can see here, the most important word is intentional. This is not about accidental gaps or bugs in your code. It's a deliberate, strategic decision to engineer these spaces into our architecture. These spaces allow the system to absorb pressure, making it way more resilient and way more performant. This really leads us to the core question that every true innovator needs to be asking. Instead of thinking, how can I make my system stronger and more powerful, we flip it around and ask, how can I introduce empty spaces to relieve the pressure? This one question fundamentally changes our entire approach. We stop building thicker walls and start designing an intelligent, flexible network. Okay, that's enough theory. Let's see this in the real world. Our first case study is about creating breathing room for your software. It uses two really common techniques, caching and message queues, to solve a problem that almost every web application faces. Here's the classic contradiction we need to solve. On one hand, an application needs to feel instant, super responsive to the user. But on the other hand, it also has to do a lot of heavy lifting, things like complex database queries or processing images. When it tries to do all of that at once, the system chokes, and the user is left just staring at a loading spinner. We've all been there. So how do we fix it? Well, as Kai is pointing out for us, we create these dedicated spaces. When a request from a user comes in, the system first checks the cache, that's our POR, which holds frequently used data for lightning-fast access. Now, for the really heavy jobs, we don't make the user wait around. We just offload them to a message queue, that's our gap, where they can be processed in the background. And the result? The main application is now free to give the user an immediate response. And the innovation win here is absolutely huge. To the user, the application feels incredibly fast and responsive. Why? Because all that heavy, time-consuming work is happening asynchronously, completely out of sight. We've systematically managed the flow of data, and that creates a system that doesn't just work, it scales elegantly. Okay, let's look at another really powerful example. This time, we're going to create shock absorbers right where it matters most, inside the database. This approach tackles a really fundamental challenge of balancing data storage with speed. So here's the contradiction. We need to store our data safely on physical disks, right? That's essential for keeping it long-term. But accessing those disks is incredibly slow compared to a computer's main memory. If every single little request for data had to go directly to the disk, our databases would just grind to a halt. So, following Kai's diagram here, the solution is a buffer. This is just another type of POR. a temporary holding area in that super fast memory. So instead of writing every small piece of data to the slow disk one by one, the system catches all these requests in the buffer. It groups them together and then it writes them to the disk in bigger, much more efficient chunks. It's a perfect shock absorber. And the innovation win from this is one of the fundamental reasons why modern databases can handle such massive volumes of transactions without completely choking. By using these porous buffer zones, they drastically cut down on the number of slow disk accesses, which leads to incredible gains in performance. It's a truly systematic innovation.
So, let's bring this all together now. What are the key principles you should be putting into your Innovators toolkit today?
First, remember that true innovation is about spatial design, not just about writing faster code. Your job is to engineer these digital sponges, things like the caches, queues, and buffers we talked about. By designing these dedicated empty spaces, you create systems that can absorb pressure, that can breathe, and that can scale. This is how we move from random trial and error to systematic, repeatable innovation. And that brings us to our final thought. I want you to look at your own projects, your systems, even your daily workflows. And I'll leave you with this one question. What solid part of your work needs some room to breathe? If you can answer that and apply this principle, you might just find your next big breakthrough. Thanks for joining us at Idea Mechanics.